Hi all, so in the previous video we saw that how an array structure could be converted into a nearly complete binary tree, and we also discussed about two terminologies, that is length of array and heap size. Right, so in this video we shall be discussing about three more notations required in this while dealing with heap. So one is parent of any index I, right? So it should be what it should be according to you. For example, if we are looking for looking for this node, so what's the parent of node 2? So it's node 1, right? So the parent of I is the floor of I by 2. Okay, so that's great. Then there is one more thing called as left of I. So left of I means if we are at node 3, then what would be the index of its left child? So as you can see that the left child of node 3 is 6, and which is clearly 3 into 2 is equal to 6. So we can say that left of I is equal to 2i. Okay, then there is similarly right. So right of I is equal to, so when let's suppose we are talking about this node 4. So what is the index of the right child of node 4? So it's 9, which is 2 into 4 plus 1. So the right of I is 2 into I plus 1. Okay, so this would give us the index of right child. Okay, so yeah, so there is something called as root of heap or root of node. So root is equal to a of 1. So this is root. Okay, so that's great. So as we discussed in the previous video that heaps are two kind of heaps. One is max heap and one is min heap. Okay, so in the max heap there is condition where a of parent of I should always be greater than equal to a of I. As in this example, this is an example of max heap. So if we take any node, for example if we are taking this node, so parent of this node should be greater than 7. So parent of 7 is 14, so 14 is greater than 7. So it's satisfying the heap condition. Similarly in min heap there is a condition where it says that a of parent of I should be less than equal to a of I. Okay, so for example an example of this could be 1 2 3 4. So this is an example of min heap, right? So if we see about this node, so the parent of this node is this, so 2 is less than 4, so it's satisfying the condition. So that's great. Then we need to see about height of a node. Okay, so this thing can be defined as the number of edges on the longest downward path from that node to a leaf, right? So for example, if we are taking this as example, and if we want to know the height of this node, so maximum edges that are there from this node to a leaf are 1 and 2. So the height is equal to 2 for this node. Okay, so yeah, then there is one thing called as height of heap. Okay, so this is the height of root. So for example, in this example, what would be the height of the heap? So we would be looking for this node, what is the height of this node. So this the height is 1, 2, 3. So the height of heap is 3 in this example. Okay, so yeah, so that's great. Then there are two most important methods when we are dealing with heaps. So we will be discussing about those methods in the next video. Till then, stay tuned and thank you so much.